Hi, I'm Carl Franklin. In this episode of Blazor Train, we're diving into streaming with SignalR. Before we get to SignalR, though, I'll tell you everything I know about streaming in general, both synchronous and asynchronous. After that, we'll fire up a Blazor app and stream our way across the landscape. So go stock up on crappy hot dogs and cold coffee, because SignalR streaming is coming up right now, right here on Blazor Train. Okay, before we get into streaming with SignalR, let's talk about streaming in general. Because streaming means you're using the iterator pattern, using yield return. It doesn't have anything to do with streams, system.io.stream, nothing to do with them. So let's take a look at this simple demo here. It's a console application. I've got this class called message. It has a nullable string property called text. And I have this IEnumerable of message method that returns messages. Now you got to imagine that this is coming from a database or some other source. You have some method that is getting data from somewhere and it's returning data to you. So all I have here is a simple iterator. I go 3 times through. Each time I create a new message with the text hello and then the number. So it'll be hello 0, hello 1, hello 2. I'm going to add those to a messages list, and then I'm going to return the messages. This is very simple. We'll start simple. So here I call get messages, and I display the messages on the console and then display done, right? Ooh, ah, done. Okay, so let's press F11 and step through this one line at a time. Here I'm calling get messages, and in get messages, I create my new list. I go through the for loop, create 3 messages, return a list. Now I iterate again through those messages, and I display them. And we're done. So let's convert this to a stream. In my get messages, rather than creating a list and returning them, I'm going to simply say yield return message, and all this other stuff goes away. Now the order of operation is going to be drastically different, but let me just run it so you can be sure that the result is the same. Hello 0, hello 1, hello 2, done. Let's step through this with F11. All right, get my messages, blew right over that, okay? Because the compiler is smart enough to know that we're using yield, and therefore we're not going to go into get messages until we actually need a message. So let's see here. Right? The first time I go in, now I create a message, and I return that message, and now I display the message. Rather than waiting until the entire sequence or list or IEnumerable has been created from the data in the database or whatever, we're going to get them one at a time as they're being created, as they're coming right out of the database and into the console. And the result, of course, is the same. Now, there's something else that we can do because we're using yield. We can, instead of creating a new message every time, in certain circumstances, and there is a gotcha here, let's do this. Let's create one message, and down here, I'm just going to set the text property. Okay? So now I have one instance of a message, and I'm just setting the properties on it and returning that same instance. Does that work? Yeah, sure does. Now here's the caveat. I'm doing this because I'm only iterating once here. If I had to iterate again, guess what? I'm going back to get messages, right? So let's put a breakpoint here, and I've got my first 3. So now I'll press F11 here. We're back in get messages again. So the gotcha is that if we need to iterate more than once, we probably shouldn't do this single instance trick. All right, so I really want to get this idea across to you that streaming is using the iterator pattern with yield return, and we're taking each record one by one from the database, from wherever we're getting it, bringing it right to the client, and then using that data or showing that data, and then going back to the data to get the next record and so on. So that's the idea of streaming. That is what streaming is. It has nothing to do with streams, has nothing to do with system.io.stream or network stream or memory stream or any of those things. This is streaming. Okay, now C#8 gives us this new feature called async streaming. Let me show you a demo of that. This is the key right here, I async enumerable of t. Now before we get into the code, a few things about async streaming. So this combines the iterator pattern using yield return with async. So without async streams, you cannot do yield return from an async method. I'll say it again, without async streaming or IAsync enumerable, you cannot do yield return from an async method. Now, because it's async, your UI can start working as soon as the first record arrives. So you get the idea, right? You have UI that's going to show a bunch of stuff, and you want to pull up the UI and have people work with it as data is coming in. To do that, we're going to use a pull operation, not a push. In other words, if you think about typical SignalR, you'd say, notify me when there's new data, and then it fires an event and stuff. And that's all fine and good, but this is a pull operation. The other thing I want to say is async streaming is not about performance. Your performance may actually degrade a little bit on each call, but it's really about scalability. All right, let's go down to our get messages. Now the message class is the same, but now the signature of get messages is async IAsync enumerable of message. Notice we don't have a task here. That's because IAsync enumerable is a task of sort. It's a value task. Value task was introduced in .NET Core 2.0 as a struct that's capable of wrapping either a T-result or a task of T-result. And that means it can be returned from an async method. And if that method completes synchronously and successfully, nothing needs to be allocated. We can simply initialize the value task of T-result struct with T-result and return only that. So it really saves on memory allocation when a task is not required to be allocated. And so this can save a lot of memory and overhead if you're accessing a lot of data and calling something that returns a task over and over and over again. Each of those allocations builds up in Gen 1 in the heap and needs to be collected with garbage collection. So if you anticipate being able to return synchronously, and you're going to be incurring a lot of overhead, in other words, you're going to be calling something over and over and over again, it makes sense to use a value task. So now, again, you have to imagine this is coming from a database. So chances are you're going to be using await. And if you mark something as async, you have to have at least one await, right? So I have something in here just to appease the compiler. But in the real world, you'd be pulling something out of a database, you'd be using an asynchronous call. So I've gone back to creating a new message, not a single message, and there isn't really any reason. And then I'm using yield return in async. Now, if I did this task of IEnumerable, I'd get this. The body of get messages cannot be an iterator block because task of IEnumerable of messages is not an iterator interface. So that ain't going to work. Now here's something different. Instead of calling get messages with await, we call for each with await. We can call get messages once, or we can call it over and over again. It doesn't matter. It's not going to be called over and over again because the compiler understands what we're doing here and makes things more efficient for us. All right, first of all, let's run this to make sure that everything's going to look the same. There we go. Same old results. Now, let's walk through it. Pressing F11 here. You notice get messages is called once the first time. There's my delay. Creating that message. Showing that in the console. And the next time we go back for another one. And there we have it. So you get it? An async stream is a stream that we've had for a while, but now we can use async and await to return data using yield return. Yield return and async is only possible using async streams. Okay, now that we understand that, let's move on to SignalR. So I have a new Blazor server application. I've called it SignalR Streaming Demo. And since we're going to be using SignalR both as a hub and as a client, we need to add the SignalR client library. There you go. Microsoft ASP.NET Core SignalR client. All right, now we need to change program CS a little bit. All right, so I've got global usings for namespaces that we're going to be using elsewhere in code. And for just the namespaces that we're using in program here, I've just got a using statement. So I've added these two statements for the SignalR demo. We're going to add SignalR. We're going to add response compression. I've added this use response compression for the SignalR demo. And then down here, I've added map hub, stream hub. Now we don't have a stream hub yet, so let's add that. So here's my stream hub here. I'm deriving from hub, which is Microsoft ASP.NET Core SignalR hub. Note the absence of using statements. I love that. I've got some links for you that this code was adapted from this documentation. This code is available at blazortrain.com, of course. And let's start talking about channels. There's basically two ways that we can stream from the server to the client, and those same two ways can be used to stream from the client to the server. So we're going to start streaming data from the server, from our hub, to a client using channels. So this is the old way, okay? This is not the new async stream way. And I'm adding this just to give you some perspective into, how kind of clunky it was to use channels in the past. So what is a channel? Well, it's simply a data structure that's used to store produced data for a consumer to retrieve and an appropriate synchronization to enable that to happen safely. That's thread synchronization, while also enabling the appropriate notifications in both directions. Now, I got this definition from an excellent article by Stephen Taub, and I've added the link here, which is a great introduction to system threading channels. So the channel has been available since ASP.NET Core 2.1. ASP.NET Core 3 introduced streaming from the client to the server. C#8 introduced asynchronous streaming using iasync enumerable, which we just talked about. So let's take a look at this method here, this hub method. So this is returning a channel reader that is a system threading channels channel reader of T, and we're going to return an int. It's called getChannelStream. I have a count, or the number of ints I want to return. I have a delay in milliseconds that I want between each iteration, and a cancellation token. I'll talk about cancellation tokens in a minute if you don't know what they are. They're very cool. So here I'm creating a channel that's bounded. In other words, it has a limit to how many items of data are in it. If you want an unbounded channel, you can say create unbounded, and you don't specify the number. Either one is going to work actually in this case, but just to show you that we can be precise about what we want, we're making this channel bound to have 10 items. Now this right here is a syntax you might not have seen before. Now this underscore is called a discard, and we're basically telling the compiler to ignore the return value. It's the polite thing to do. We're just calling this write items async, even though it is awaitable. We're not going to call await. Otherwise, if we did use await, we'd end up waiting for all the items to be written before returning the channel back to the client. So let's see what write items async does. We pass in the channel writer, the count, the delay, and the cancellation token. Now I've got this local exception, and I'm setting it to null. And if I don't have this, what John Skeet calls the damn it operator on here, it's still going to run, but it complains a little bit. And it says, converting null literal or possible null value to non-nullable type is not a good idea. But I know that it should be null, and I can just use that damn it operator, as John Skeet says, to say, no, I really meant to do this. It's okay. And so now we're going to, in a try catch, create a for loop for the number of iterations and count. And we're going to write to the writer asynchronously that value. So now here's the cancellation token. What's cool about the cancellation token is it can be passed down the chain, and the caller can use it to cancel the operation, and then everything exits gracefully. So I can even pass that to task delay, right? So if we're delaying for a second, and then somewhere inside that 1 second, the cancellation token gets set to cancel, it can bail. And then finally, after we're done with all this, we're calling writer complete, and we're passing the local exception, even if it's null. So this is a lot, right? It shouldn't be this difficult. Well, anyway, it is. Let's write some code in index to exercise this. Now, before we can execute any code against this, I've got to add a using statement to my imports, just for Microsoft ASP.NET Core Signal Client. And now we can hijack the index page. Now I have the code for all 4 demos in this index page, but I have them rolled up in regions. So the first region right here is streaming using a channel from the server to the client. This is my code for that. But let's go down to onInitialized async. I've got my hub connection, and my navigation manager is injected right up there so that I can get the absolute URI of StreamHub. I start the connection, and now I have 2 handlers for receiving data. We're not going to need this until the second 2 demos, but I thought I would just show you that there they are. We're just pulling in a message string and showing it in the UI. And there's 2 of them. There's one for channel and one for async, but we're not using them yet. All right, let's talk about this one right here. Get channel stream when we click this button. And I have some text here. Channel button text. And I'm showing a channel message. So let's go down and look at this code. My channel message is initialized to nothing. My channel button text says get channel stream. All right. If it says that, that means when we click on this, we're going to go ahead with the demo, and I'm going to set the text to stop. So it's either one or the other. I have a cancellation token source that's nullable, and the connection is nullable too. And if you don't know about nullables, check out the .NET Show episode 15. It's a nullable world. We're just living in it, because I went through all of that stuff there. So here's my get channel stream that gets called when that button gets clicked. And because it's a nullable world, my hub connection might be null, just return. And if channel button text is get channel stream, we'll change it to stop. We'll create a new cancellation token source. And now I'm creating a channel from the hub. specifying that we want to receive 10 consecutive ints, exactly 500 milliseconds apart. So hub connection has a stream as channel async of int. This is my method, get channel stream, right? This is in the hub, get channel stream. I want 10 iterations. I want that to be 500 milliseconds apart, and I'm passing the token from the token source. And now I have to wait asynchronously for the data to become available. All right, so SignalR is going to push data to me. So I have to basically wait. I have to wait here to read async. And then when I have a value asynchronously, I'm going to read all the currently available data synchronously before waiting for more data. So for that, I'm going to use the channel try read, and we're going to read out of the channel and put it into this variable count. And then while I have data, I'm going to set channel message to received count, invoke status changed, and then I'm going to go back and try to read again. So this is basically waiting on the client for the server to push data to us. All right. Now, if the channel button text does not equal get channel stream, that means it equals stop. I'm going to stop the stream, which cancels the token source, and then I reset the button text to get channel stream. And I'm also going to clear the channel message. So here we are. I'm going to say get channel stream, and now you can see received all the way up to 9 and then done. Now if I stop it, it's done. Okay. So if we were to put breakpoints in here, we'd have a breakpoint here. On the stream hub, we'd have a breakpoint here. And then these are going to go back and forth. So here's get channel stream. Okay, in the stream hub, we're writing the first value. We got the first value, we show it. The stream hub gets the second value, writes that, etc. Bouncy, bouncy, bouncy. All right, in the stream hub, let's move on to async stream. Now you saw all that code. Look at this. That's it. Remember our iasync enumerable of int, right? So this is the same thing, except now it's in SignalR. It's on the server. And we can have this locally if we wanted to, but SignalR has just let us completely abstract it. So here's my for loop. I'm going to check the cancellation token so the server will stop producing items if the client disconnects or that cancellation token was invoked. I'm going to yield return my value I, and I'm going to delay. Now, what does the code look like in the app? All right, well, I have my get async stream button and an async message and an async button text. So this is get async stream. It's the same plumbing code here. If my button text is get async stream, I'm going to set it to stop, create a cancellation token source, and then I call hub connection stream async with the same values that I passed the channel, the create channel async method. And now, just like in the console app, I'm calling await for each on each number in the stream. And then I'm showing it and invoking status changed. And when I press stop, stop the stream, and again, set async message to an empty string. Boom. Now, these two can operate independent of each other, of course. And not only that, but I could pull up another browser and do the same thing. So each of these is a completely separate stream. Isn't that much cleaner, right? It's cleaner on the client. It's cleaner in SignalR, much, much cleaner. And the abstraction is just all done magically for you. All right, in the hub, let's talk about sending data to SignalR as a stream and then distributing that to all of the other clients. So using the channel to get a stream from the client, we basically have an async task upload stream to channel, a channel reader of string, and we're waiting here on the server. We're waiting for it. And it's the same thing that we did on the client with the channel. We're just doing it backwards now. Once I get an item, I'm going to do clients all send async, because there really isn't any benefit to doing a stream download when the data is created by another client. All right. Difference. In these first two examples, streaming from the server to the client, the data was on the server. Think of it like a movie, right? You're streaming a movie, chunks at a time. You're streaming audio, chunks at a time. You're streaming stock data, which you're getting from some API, and you're streaming that. The data originates on the server, okay? But when we're talking about a demo streaming from a client to server, we want one of the clients to generate a stream of data and send that to the server. And then we want the hub, the server, to distribute that to all of the other clients. And for that, we already have a mechanism for that, clients.all.sendAsync. And this is where our receive channel stream data comes into play, because in the stream hub, that's what we're invoking, passing that string. And so we set our receive channel message to that and invoke status changed. Now, what does the code look like? So here's our code to stream using a channel from the client to the server. Right up here, it's this guy, stream channel to server. We've got some text and a message. Again, it's a nullable world. Checking the button. We're creating an unbounded channel of string because we're going to keep sending data until the client presses stop sending. So because we're initiating it, starting it, and stopping it, I need a Boolean. Send channel canceled. And I have that right here, right? And I'm going to set that to true when I press stop, right? So that's how my while loop knows when to stop sending. So all I'm doing is I create a value, channel, and the date time now, and then writing that with channel.writer, write async. So again, it's backwards. We're using a channel, but now we're generating that channel on the client and then writing to the channel, which sends it up to SignalR. So again, channels, the old way to stream, but I'm putting it in here because it's important to know. And also when we're done, I'm going to set receive channel message to an empty string. All right, let's see how that goes. So stream channel to server. Now I'm not only sending from the client, but I'm also receiving in the client because, remember, we're calling clients all send async. That includes the sender. All right, so let's do our two browser thing here. Let's pull this up in another browser. And now look, this browser is receiving, even though this one is sending. Could I send from both at the same time? Sure, I could, but I didn't put in the locks and the insurances to make that happen right, because it's just a demo. So if I say stop sending here, I could send from here and stop. Okay. Now the reason this didn't clear is because we didn't know that everything stopped, so it's no big deal. So that's streaming the old way from the client to the server. let's talk about streaming from a client to the hub to everybody else using async streams. Again, very, very simple. So we have public async task, upload async stream. We're passing an iasync enumerable of string, the stream, and for each item, we're awaiting send all. That's it. That's all we have to do here. Now on the client, let's look at our stream async to server right there with button and a message. Again, we have a canceled Boolean and checking null. If we're ready to go, all we do is await hub connection, send async, upload async stream, and then I've actually got a method to create that client stream data. I could use an inline, but I wanted this to be really clear. All right, so that this button handler right here is very simple. It either sends async, the stream, the iasync enumerable, or it cancels. So look at this. This couldn't be easier, and I know you can already recognize what we're doing here. We're setting send async cancel to false, and while it is false, we got a string value, and then we're calling yield return value. And then we're delaying for 1 second. Simple, simple, simple. There you go. And while that's happening, we'll pull up Edge here, completely different browser. And you can see that it is also receiving the stream. So when would you use this? Okay, if one of the clients and not the server is creating the data and needs to stream that data as it's coming from wherever, from a database, from a video file, from a camera, from whatever, you can be sending those chunks in a stream, and each client will be receiving those chunks as they're received on the server. Cool, huh? Hey, that's my talk on SignalR streaming. Now back to you in the studio, Carl. You know, this was a fun episode for me. I've been dealing with data streams of one kind or another for more than 5 years. 6, 7, 8 years, 9, 10, 11, 12 years. Okay, over 20 years, I reckon. Anyway, streaming just keeps getting better. And now it's more scalable and easier than ever to implement using C#. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a trail.